So let's go ahead and talk about the ratios of these parallelograms. From the rectangles, we know if they have equivalent ratios that they are similar figures. Well, let's see which ones in this picture are equivalent ratios and which ones are similar. We're going to do the same thing and make a ratio of height to width. So for parallelogram E, it's going to be 16 that was 12, 16 to 24. For parallelogram F, we're going to have 8 over 12. And for parallelogram G, it's going to be 6 over 9. Well, remember, we're going to have to reduce this to figure out which one's the similar figures. Well, let's go ahead and reduce the first one. We can reduce this to 8 over 12. Well, notice we can reduce 8 over 12 even more and change that to 4 over 6. Notice we can even reduce that even more and change that to 2 over 3. So the first parallelogram can reduce to 2 over 3. Let's talk about F. 8 over 12 can be reduced to 4 over 6. But I can reduce that even more. This can reduce to 2 over 3. Okay, well, let's look at parallelogram G. 6 over 9, we can reduce that by dividing by 3. And that can reduce to 2 over 3. So one thing I would like you to notice is that all three of these ratios are equivalent. So by our rule, technically, all of these should be similar. But there is one problem. E is actually not similar. But why not? They all have the equivalent ratios. Well, by our rule of similarity, all similar figures must have congruent angles, which means all angles must measure the same. Well, let's look at their angles. 52 degrees, 52 degrees. This is 68 degrees. Because its angle is not congruent to the others, this guy is not similar at all. The other two are in fact similar because their ratios are equivalent and their angles are congruent.